All right, this is Coach Williams here. We're going to go over section 9.2 notes. 9.1 was actually dealing with radicals. We've done some stuff with radicals, and we felt like it was going to be a lot of repeats of what we had done, and we're going to be able to spiral some of that into the next few sections of this unit. So we skipped 9.1 and jumped into 9.2. This is going to be solving quadratic equations by graphing. A lot of this is going to be involving the calculator, so make sure you've got a calculator handy where we can go over that, and we'll show you how to do that in just a second. All right, so first thing we need to establish, which we have gone over, this is review of a review of a review, is a quadratic equation, and that's simply going to be y equals ax squared plus bx plus c. This is actually standard form. If you want to make a note, this is the standard form of a quadratic equation. And what we're looking for on the quadratic equation is what? What are we looking for it to be a quadratic or classified as a quadratic equation? What little thing tells us it's a quadratic? It's the x squared, right? Okay, so we're looking for that right there. That's what tells us that it's a quadratic. That little square, that degree of 2, tells us that this equation is a quadratic equation. Now, we can just have the x squared, or we could have the x squared and the bx, or we could have the x squared and the c, and it's still going to work, okay, as long as we have this x squared. If the x squared goes away, it's no longer a quadratic. If the x squared goes away, what is this? That's a mx plus b. That's a linear equation, right? So if I took the x squared away, I don't have a quadratic anymore. I have a line. All right, so that means that, as we've qualified before, a cannot equal a 0. So a can't be 0 because if a is a 0, then that takes the x squared and it goes away and becomes a 0, so then we don't have a quadratic anymore. Okay, and then also, just as a side note, you may see this y be written as an f of x. So you may have f of x equals ax squared plus bx plus c. So you may see it written like this, y and f of x. It doesn't really matter. It's the same thing. Okay? All right, so now on to the solving of the quadratic equations by graphing. What are the steps we're going to go through to solve them by graphing? First thing is, we're going to see that it is, step 1, written in standard form. And so you'll see this right here is the standard form that we're talking about. Ax squared plus bx plus c equals 0. All right, once we get it in that form, and make sure the zeros on the right or left, it doesn't really matter which side. We'll talk about that more later. As long as everything's grouped together on one side and you have a 0 on the other side of the equation, or the equal sign, then we're in good shape. The next step is going to be to graph the related function. Okay, this part here, when we graph the related function, step 2, we're basically going to go into y equals in the calculator. Okay, and we can still graph it if we wanted to manually. Finding our axis of symmetry, using the c as our y-intercept. That's still, don't forget that, that's still our y-intercept, right? So we could look at that, we could do the axis of symmetry, we could find the vertex, we could find some points manually, but for sake of time right now and learning to find solutions using the graph, we're just going to put in the calculator, and we're going to use the y equals in the calculator to help us solve. Okay, so that's going to be the second step. And then step 3 is going to be to find the x-intercepts. Okay, the x-intercepts, if any. So sometimes there'll be x-intercepts, sometimes there won't. All right, and what we're talking about here on the x-intercepts, we're talking about the zeros of the function. We're talking about the solutions. And you may also remember we called these roots. Okay, so you may see it written as one of those ways. So the solutions, the roots, the zeros of this standard equation of a quadratic are the x-intercepts of the graph. And what does x-intercept mean? It's where it crosses what axis? The x-axis. Exactly. Okay, so let's move on to the number of solutions of a quadratic equation. And I'm going to draw a little graph example off to the right just to demonstrate what we're doing here. Okay, this is my x-axis, this is my y. And so on the first one, okay, the first one says 2 real solutions. It means it has 2 places where it crosses the x-axis, okay? So I'm going to highlight that in this pink color here. And I'm going to draw a pink graph that demonstrates that, okay? So I could have a graph that comes in here like this, and goes back up like this, and you'll notice that it crosses the x-axis at these 2 points. Okay, so that's when you have 2 real solutions. All right, 2 real solutions. All right, on the next one, we're going to have 1 real solution where it only has 1 x-intercept, and generally this means it just touches the x-axis. It doesn't actually cross it. It just touches it and then, carries on. So this one we're going to demonstrate in blue. And you'll see this, and it may be, again, this could be flipped the other way, and the one I'm fixing to draw could be flipped the other way too. But you may see a graph like this, and it only touches the x-axis in 1 point. Okay? So you could label these if you didn't have colors. You could label this. This would be 1 real solution. This one would be 2 real solutions. And then lastly, we're going to have no real solutions, and it does not cross the x-axis anywhere. And you may have a situation where you've got a graph that looks like this, and there you'll notice it's pretty obvious and evident it doesn't cross the x-axis, so there's no solutions. Okay? All right, so that's an example of the types of solutions or the number of solutions you could have with quadratics and what they kind of look like. Let's look at the extra practice. And this is where we're going to start using the calculator to help us out. Okay, so solve the equation by graphing. First thing we do, step 1, is it in standard form? And this one doesn't have a C, but it is in standard form. Everything's on one side, zeros on the other side. And so I can just put this right into the calculator, and we'll do that by clicking on y equals on our calculator. And then we're going to put in this equation, x squared plus 4x equals 0. So I'm going to have x squared plus 4x equals 0. We're just going to put in the x squared plus 4x because we're doing the related function y equals that equation. Now I'm going to graph this equation, and you should see on the graph that it's crossing at 2 pretty obvious locations. I mean, it's going to cross at what's this location right here? X is going to equal what? 0. And then x equals what here? -4, right? So it's going to be at -4 and 0. Well, the graph points and indicates that to us pretty fast. But then we could also look at, we know we can go to second graph, which takes us to the table. And we're looking for where y equals 0. That's the x-axis, right? Everything on the x-axis, y equals 0. So -4, it shows us here, is one of the zeros. And then the other 0 here is at 0. So we could look at the table, or we could look at the graph, and that's going to help us find the solutions or the zeros of the function. Now, I'm going to put these points in. So I'm going to go over here and say, well, there's a point at 0, 0. We know that. There's a point at 0, -1, 2, 3, 4, or -4, 0, I mean. -4 and 0. And then just to add to this, I know that the axis of symmetry is right between these 2 points, so it's going to go down through there. And so if I know that's axis of symmetry, then all I need to do is look for x equal to a -2 to find my y value, and that gives me what? What does that give me? The vertex. Yeah, the vertex. All right, so if I go to -2, what is the y value at -2? It's -4. So I'm going to go -2, -1, 2, 3, 4. That gives me the vertex. And then I can draw this, pretty decent little drawing of the parabola. And that's going to give me the graph of it. And like we already knew, and the graph tells us here, the 2 solutions for this are going to be x equals a -4 and x equals 0. And that's really all I need. I just need those 2 solutions. We know it crosses in 2 locations, -4, 0. So at x equals -4, x equals 0, those will be the solutions by graphing. All right, number 2. Number 2, is it in standard form? No, it's not. So we're going to have to do some moving around. And this is where we need to stop for just a second and just make something clear. It doesn't matter if I take the x squared to this side or if I bring everything over here to the left side. Okay? All that's going to change is the direction of the parabola. It's going to open up if this is positive, and I move it over to the right, it'll open up. Okay? If I moved everything over to the left side, it's just going to open down. But it's still going to have the same roots. So it's basically going to just swivel on the x-axis. It's just going to flip over the x-axis. It'll still be the same roots, but it'll just point up or down based on which direction I go with the terms here. Okay, so I'm going to show you both ways. I'm going to actually take the x squared and go to the right with that one. I'll move it to the right and make it positive. When I do this, it's going to make this x squared positive. I'm going to have a 0 equal to x squared. Remember the order. The squared term comes first. Minus 2x plus 1. Okay? All I did was move the x squared to the right. It's negative here. It'll be positive on the other side. All right, now I'm going to graph this one first. Okay, so I'm going to put this in the calculator. Go to y equals. I'm going to have x squared. I'm going to minus 2x, and I'm going to add 1. Okay? And then I'm going to do the graph. And we'll wait on this super fast, technologically advanced calculator here to graph it. And you'll notice that it only touches the graph at one spot, or the x-axis, I mean, at one spot. Where is that? X equals positive 1, right? So I'm going to go ahead and write that down, okay? I know this is supposed to be x equals positive 1. If we look at the table, go to second graph, takes me to the table. I can find the 0 of the function right here, where y equals 0. You'll see that x is a 1. So we know that that 1 is correct, right? And looking at this graph, I can go ahead and plot me a point right here at x equals 1. I can also look at this right here. I'm going to highlight it in a different color here. What is that right there again? What's that called? The y-intercept, right? So I know it's going to cross the y-axis right there, and being that this is my vertex, I can put another point over there, right? I can just mirror it across that little axis of symmetry line, right? It's symmetrical both sides. And so I could draw the graph of this function just like that. Okay? And that works. This is my answer. X is going to equal positive 1. All right. Now, if I had chosen to take all of this to the left side and then the x squared would have been negative that way, let me show you what happens. Okay, if I take everything here and go to the left side, I'm going to write it down here on the bottom. I'm going to have a negative x squared. I bring the negative 2x across, makes it positive. So plus 2x. Bring a positive 1 across and changes the sign, so it makes it negative. And I'll have the 0 on the right. Now let's put that in the calculator and see what happens here. Okay, so y equals, I'm going to insert a negative sign. I'm going to change that to a positive and change this to a subtract, an add and a subtract, right? I'm just changing the sign to match this right here. Now when I graph this, you're going to see the graph is just going to flip across the x-axis. It's going to flip, and now my answer is still a positive 1. The graph just goes the other way. Okay, so if I'm doing this again, my y-intercept is now a negative 1. I'm still at positive 1. I know that's my line of symmetry, so I can come up here and I can draw this. So either way you decide to go when you're setting this up in standard form, if you go to the right or to the left, making the x squared positive or negative, it's still going to give you the same zeros or roots of the function, so you're in good shape. Don't panic if you do it one way and your neighbor does it the other way, and it looks different at first. You'll still arrive at the same answer in the end. Okay, so this one had one solution here. Let's look at number 3. It's already in standard form, so we're just going to plug this into y equals. We're going to have I'm going to delete that negative sign out there. X squared plus 2x plus 4. Whoops, plus 4. X squared plus 2x plus 4. We're going to graph it. And you'll notice on the graph that it doesn't even get to the x-axis. So what do we say here? This has no real solutions. Okay, you could put a little 0 and a line through it because there are no real solutions for number 3. Okay, and sometimes that's the case. The graph of this one, you know, it looks like it goes through, if you're looking at the graph here, it goes through probably the vertex is a -1 and 3. We know it crosses at 4. 1, 2, 3, 4. It's my y-intercept. Looks like the vertex is right about there. I'm just going to give kind of a demonstration of the graph itself. And from that, we know it never even gets to the x-axis, so there are no real solutions. Okay, on to the back. Again, we can put these right into the calculator. We're going to have y equals, this is an x squared, it's minus 5x, and it's still plus 4, so we'll just leave that in there. All right, we'll go to graph that. And on the graph of this one, you're going to notice it goes over here to the right side of the y-axis, so it's over here. But it crosses at 2 whole number, whole integer points here. What is the x value here and here? X equals 1 and 4. All right, and we can check that by going to the table. So if we look at the table, we'll look for the y value to be 0. We have an x value of 1. We go into this one. The x value is 4. So that's it. We're going to go at 1. We've got a solution. At 2, 3, 4, we have a solution. So know that those 2 points are, definitely part of the graph. And then this one's going to be a little tricky. I'm not really concerned about this too much, but notice the axis of symmetry would be at about 2.5, right? So 1, 2.5, because this actually is 3 apart. So we have to go halfway between it. So if I wanted to find out what the value is at 2.5, I'd have to go in here and look at it, or maybe I'd have to do the find max or min, calculate that. We've done that before too. But looking at it, if we go to this table, or looking at the graph, if you go between 2 and 3, right, it's going to be a little further down than -2, so we'll just guess at this point. Again, if I put this in here, it ends up being about 2.25. So, but if I put this in, or if I don't, not actually worried about this point too much, I'm just going to give it a value. I know it's going to cross at 4. 1, 2, 3, 4, because that's my y-intercept again. So we know that point's going to happen. We can go across and put another point there if we wanted to. Now we got 5 points in here. One of them's kind of a guesstimate, but again, we're not too concerned about the graph at this point. What we're really concerned about is where it crosses, and we know that it's going to cross right there at 1 and 4. So x equals 1, x equals 4. That's the main part that we're looking for on number 4. Okay? All right, number 5. We're going to put that in the calculator into y equals. Like we said, this is going to be a lot of calculator work. Plus 6x, plus 9. I'm going to graph it. It only touches in one location. What is that location? X equals what? -3. All right. So, and we know it's going to cross at 9, which is way up here somewhere, and we know it comes in at -3 and touches in, and it's way up here somewhere. I don't know exactly where it's going to be there, but again, this is not too critical at this point. We're just trying to get the intersections or the intercepts of the y-axis. So this is just going to be y equals a -3. Okay, and that is the answer for number 5. Super simple, isn't it? This is very easy. All right, the next one is not in standard form, so we've got to do a little bit of moving around. Again, it doesn't matter which side you put the x squared on, or if you move the 2x minus 6 over to the other side. Doesn't matter which side you do it on, it's still going to have the same roots. So let's move. I'm going to move this whole thing over there, just to give you a little practice of changing signs. And plus, it keeps my x squared positive. So when I move the 2x, it's going to make that negative. When I move the 6, it's going to make it positive. And then that will equal 0 on the right side. I'm going to put that in y equals, I have x squared minus 2x plus 6. I'm going to graph it, and you'll see here from the graph that it's not even going to touch the x-axis. So this is going to, it goes through positive 6, 1, 2, 3, 4, 5, 6. If you chose to move it the way I did, it'll go through positive 6. Looks like it has a vertex around x equals 1, so we'll just throw this on here just to have something to graph and look at. This one will have no real solutions. I'm going to abbreviate that. No real solutions, and so we won't see anything there, where it's not going to cross the x-axis anywhere. If you had chosen to do a negative version of this, moving the x squared over to the right, you would have just seen a flip of this across the x-axis, and you would have seen something down here like this. Okay, if you had done the negative version, it had just been across the x-axis, mirrored across, and pointed the other way, still not touching the x-axis anywhere. All right, the last part of this is the easiest of all. We're just looking at the graph, and we're saying, okay, where do the intercepts happen? We're going to see an intercept here, here, and here. It crosses the x-axis at those 3 spots. So what are the x values at those 3 spots? 0, 1, and 2. We're done with number 7. That's how easy it is. All right, here we're going to have one there. We're going to have one that touches right there. So we'll have 2 solutions. X is going to equal what? Negative 2 and 1. Yes, we're going to have negative 2 and 1. That's the answer to number 8. What about number 9? We have one there, and one there. So we'll have 3 locations where it crosses the x-axis. We have one at negative 1, positive 1, yes, and 3. Good job. Good job. And then the next 3 are just the same. We're going to have to just look at where it crosses the x-axis. So x is going to have, we're going to have 3 values here. We're going to have a negative 3, negative 2, and negative 1. Very good. Here again we're going to have 3 solutions. X is going to equal a 1, 2, and 3. And then the last one, again, 3 solutions, 3 locations where it crosses the x-axis. X is going to equal negative 1, positive 1, and a positive 3. Okay? And that's pretty easy. That's just what we're going to be doing on our practice. You're going to see some problems like this. You're going to see some problems where we have to graph it to find the solutions. And you'll see some problems where you just put it in standard form, and that just means we're putting it in this ax squared plus bx plus c form, and that's all you're having to do on that. So this should give you a real good head start on the practice, and you should be able to complete that in just a matter of no time. All right, you have a great day.